Good morning, my good mud fossil friends. It's Roger again today talking about the nuclear core. And what are you looking at? You're looking at a cube of particles. And you say, well, what's that got to do with a nuclear core? That's what a nuclear core looks like, only it will take on a roundish form and the exterior will become basically coated with negative particles, giving the core a negative propensity, keeping electrons in their cloud. And I will show you that in a second. This is basically electron flood theory. That core is in here. It ends up having a negative net negativity to it, so that the core itself is net negative. Everything else negative wants to get to those positives. They can't get there because there is a net pushback from the core. I'm going to show you that in a little toy right now. Alright, this guy right here this is Latham's Crazy Machines, and he's going to make a nuclear flooded core. Here it goes. Alright, now what you look there is 6 negative particles, magnets, inside of a neutral brass ring. And he's going to put in a positive core, which will be basically the same thing as my electron flooded core. And then more electrons will want to get into the center, and they will be repelled by the coating of negative particles, like I said, would be a coating around the nucleus. And then your electrons would float in their orbital. So here goes. See, there's your positive. It wants to go to those. He puts it in the center. So now you have a positive center with electrons flooding it, which is the negatives. Now, boom, there it is. That is quantum mechanics. You're looking at it right now. And additionally, you will notice it's held between these two forces. So not only is it held at a distance, it's held in its exact distance. Now, if there was 6 electrons in there, you would have 6 of these around, and they would be locked in position. Basically, they'll float around a taste, but they're not going to really go too far from that deal. Now, as you add 50 or 100 out there, they will line up in positions that are dictated by the ones that are pushing them. All right, so here we go. That is tight. Now, that is a solid lock. That is an electron in its orbital. As it starts to shake, it means what he's doing now is there's electrons coming in and bumping all around in here. And that's what he's doing by shaking the core. So now that electron in its orbital becomes bouncing around a little bit, but it's going to hang in there. It's going to be tight. But at a certain exact energy, it will leave the core and go flying away like this. And then when it does, that is called light, and that is the frequency it leaves at. And the distance from the core and the quantum mechanics of the electrons determines how much of a frequency it takes to pop that out of there. And every frequency has a color. The very long, slow frequencies are red. The very short, powerful frequencies are blue. Hydrogen has blue and it has red. Hydrogen controls a distance 21 centimeters. 21 centimeters around itself. But it also has an electron virtually locked onto the nucleus, and that gives you that blue frequency of light because it's really short. It's like this one, it goes, and boom, it goes. The one way out here, it has to be woof, and that's what affects the distance farthest out. All the other elements, have a batch of different colors that represent their actually atomic makeup. It actually represents the orbitals of the electrons and in their shells. Some way out here, some in here, some in here, some way down here. Every one of them is going to create a different color energy. That's how the nuclear core works. Now, if you walk into a classroom, they will tell you that there's a gigantic proton in a hydrogen. It's 1,836 times bigger than a tiny little electron. They have the same voltage. One of them is plus, one of them is minus for some reason. 1,836 times difference. But this only has one electron volt and that has one electron volt. This is plus, that's minus. That is not correct in any way. Not a thing about this is correct. That electron would be solidly locked to that proton if this was a fact, and it is not. Additionally, inside of protons, they think they're all positive forces attached to each other, which never is going to happen. They don't do that. They push away from each other. So then they come up with some ridiculous statement that, oh, well, that's because it's the strong nuclear force. It overcomes the opposite that it's supposed to do. It's insanity. And then they say the weak nuclear force is a neutron. It has one extra electron, and the electron goes flying off, and you're ended up with a proton. It's not. It's an extra electron, yes, but that extra electron is glued to a bazillion other positives and negatives in the center, and it's weak force because it's extra, and it pops right off. That's all that is.